I honestly don't understand how there are people who don't find science exciting. Yes, I know that pinpoints me as a science nerd. No, I don't care. I just can't fathom how you wouldn't want to understand better how the universe works. This comes up because of an article that I ran into by Jake Parks over at the site Astronomy. The article is entitled, "Star is Confirmed Single and Ready to Test Einstein's Theory." Despite the sound of it, this is not about a nice young Hollywood actor who is ready to go out on the dating circuit. It's about a confirmation of Einstein's general theory of relativity called gravitational redshift. The idea here is that the presence of a massive object actually warps the fabric of space, rather in the fashion of a bowling ball sitting on a trampoline and depressing the surface. In fact, this is what gravity really is. The fact that the Earth travels around the Sun in an elliptical orbit is because the Sun's enormous mass actually bends the fabric of space, and the Earth traces out an elliptical path following the curvature of that space. Picture someone rolling a marble toward the bowling ball on a trampoline that I mentioned earlier. Where it gets really interesting is if you have light traveling near an extremely massive object, not only does its path bend, it gets stretched out. In physics terms, it gets redshifted as it tries to climb out of the gravity well. It's never been observed directly before, but astronomers have a good chance of observing it soon. There's a star called SO2, which from our perspective will be passing in front of Sagittarius A, which is the black hole at the center of the Milky Way galaxy. As the star moves between us and the black hole, its light should be gravitationally redshifted, which would be a major win for Einstein's theory. Tuan Do, the deputy director of the Galactic Center Group who co-authored the study, had the following to say. "It will be the first measurement of its kind. Gravity is the least well-tested of the forces of nature. Einstein's theory has passed all other tests with flying colors so far, so if there are deviations measured, it would certainly raise lots of questions about the nature of gravity." It was recently proven that SO2 is not a binary or double star system. If it had been, it would have significantly complicated the possibility of observing gravitational redshift from it. Devin Chu, a graduate student in astronomy at UCLA who also co-authored the study, had the following to say. "We've been waiting 16 years for this. We're anxious to see how the star will behave under the black hole's violent pull. Will SO2 follow Einstein's theory, or will the star defy our current laws of physics? We will soon find out." Can't you just hear the excitement in his voice? I can already hear the naysayers. How much money will this cost? Will it generate any useful outcomes? I don't know the answer to the first question, and I don't much care. As far as the second one, the answer is we don't know, and that's the point. There are hundreds of discoveries that were made by scientists who are doing what we call basic research, but amounts to just messing around. Here are a few of my favorites. The first is Henri Becquerel. Becquerel was investigating the effects of phosphorescent rocks on photographic plates. He had a bunch of plates wrapped in black paper and used a rock to weight them down. When he developed the plates, he found that there was a smudge in the middle of them that didn't seem to be from anything he'd done. What he didn't realize is the rock was a uranium ore. Becquerel had just discovered radioactivity. Roy J. Plunkett was experimenting with chlorofluorocarbon gases that he thought might be used for coolants. One of them didn't work so well, but he found that it had condensed into a solid film on the inside of the container. Further, he found that solid film not only had a very low coefficient of friction, but that water and other substances didn't seem to adhere to it. He named it Teflon. George Beadle and Edward Tatum were investigating something that very few of us would care about, which were metabolic pathways in a mold called neurospora. They found that certain varieties of the mold were unable to metabolize certain nutrients. This was mystifying until they realized that what it meant was that they were missing key enzymes. Then they realized that those key enzymes were missing because there was a defect in one of the genes in the mold. This led directly to the one gene, one enzyme hypothesis, which is the underpinning of our understanding of how genes make proteins. Henri Coover was experimenting with plastics in the hopes of finding one that would be usable for making the lenses in gun sights. He was investigating a class of compounds called cyanoacrylates, and he found that they didn't seem to be much use in making lenses because they were too sticky. One of them, though, struck him as being useful for something else. So, he sold the patent to it to Kodak. They named it superglue. In the early 1990s, some investigators at Pfizer were working with a compound called UK-92480, which they thought might be usable for opening up the blood vessels in people who suffered from angina pectoris. It worked okay, but then the researchers' ears perked up when they found out that the male test subjects had a very unusual reaction to consuming it. They patented it under the name Viagra, and it has brought great happiness lo unto this very day. And so on and so forth. My point is that we need to be doing basic research. No, the gravitational redshift experiment may never lead to something practical. The point is, we don't know. If we limit research to what we already know is going to have a practical application, it will hobble science, and who knows what discoveries it will cheat us of. Besides, there's a value just in knowing. We're at the point in our technological development where we can actually unravel the secrets of the universe, and that's worth doing for its own sake. The inspiration and joy we get for understanding one more bit of the universe is a worthwhile end in and of itself. As the eminent astronomer Carl Sagan put it, somewhere, something incredible is waiting to be known. If you enjoyed this video, please give us a thumbs up. Our resources are down there, and please subscribe to our channel. Thank you.